Hello everybody, my name is Ananya Kantraj. So today I'm here with another video of the subject computer network. So let's look into the index of the subject. So today we're going to study about the abstract, introduction, literature review, research methodology, outcomes and conclusion of the research paper I've used here in my video assignment. So the abstract says that the paper presents a robust rateless space-time blocking coding, that is SDBC framework for millimeter wave massive MIMO systems addressing the challenges of high data rate transmission and reliability in dynamic wireless environments. Unlike traditional fixed rate SDBC schemes, the proposed rateless SDBC dynamically adapts to the varying channel conditions without requiring feedback on the channel state information. So the design leverages the sparse nature of waves, channels, and the large antenna arrays and massive MIMO to achieve the high spectral efficiency and resilience to the channel impediments, such as path loss and blockages. The stimulation results demonstrate that the proposed scheme significantly enhances the system performance in terms of bit error rate and throughput under the diverse wave channel scenarios, making it a promising solution for the next generation wireless networks. Introduction. So the introduction of the robust rateless space-time block coding for wave massive MIMO system highlights the increasing demand for high data rate and reliable communication in the next generation wireless networks. Millimeter wave massive MIMO, that is nothing but these systems are positively, they're positioned a key which enables due to their ability to prove the substantial bandwidth and support for massive connectivity. However, these systems face significant challenges, including severe path loss, signal blockage, and dynamic channel conditions inherent to MMV propagation. To address these issues, the paper introduces a robust rateless space-time block coding approach. Traditional SDBC methods offer a fixed rate transmission, which can be inefficient in highly variable MMV environments. So rateless coding, by contrast, dynamically adjusts the transmission rate based on real-time channel conditions, eliminating the need for frequent channel state information, feedback, and reducing the latency. So the introduction emphasizes the novelty of combining the rateless coding with STPC in the context of M-Wave MIMO. The proposed framework aims to enhance the system robustness, spectral efficiency, and reliability, laying the groundwork for the future wave communication systems that can adapt to the diverse and challenging operational environments. Coming to the literature review for the paper robust rateless space-time block coding for MM-wave massive MIMO systems, it explores the key advancement in MM-wave communication, massive MIMO, and space-time block coding STBC, while identifying the gaps in current research. A millimeter wave communication offers high bandwidth and supports the growing demand for high-speed data transmission. The massive MIMO, with its large antenna arrays, improves spectral efficiency and link reliability. However, the MM wave signals are highly susceptible to the path loss, blockage, and rapid channel variations. So the review highlights the existing works that focus on the beamforming and hybrid pre-coding as common solutions to mitigate these challenges, but notes their limitations in the dynamic environments. So the STBC has been widely used to enhance the diversity and reliability in MIMO systems. The classic fixed rate STBC schemes, such as the Alumauti coding, provide a robustness against the fading but are not flexible in adapting to varying channel conditions. The review points out that while STBC improves performance in stable channels, its fixed rate nature is less effective in dynamic wave scenarios. The rateless coding, such as Luby transformation and Raptor codes, dynamically adjust the coding rate based on channel feedback or reception quality. So the adaptability makes it well suited for the environments with fluctuating channel conditions. Previous studies have explored rateless coding in general MIMO systems, but limited work has focused on its application to MI and wave massive MIMO combined with the STBC. Coming to the research methodology, the study begins by defining a comprehensive system model for MIM wave, massive MIMO. This includes the characterization of MM wave channels, incorporating their sparse and high dimension nature. The model considers both the line of sight and non-line of sight components to capture the unit propagation characteristics of MM wave frequencies. Massive MIMO is modeled with large antenna arrays at both the transmitter and receiver, leveraging beamforming to mitigate the path loss and increase signal strength. So an old rateless SDBC scheme is developed dynamically to adapt the transmission rate based on the channel conditions. Unlike the traditional SDVCs, which operates a fixed rate, the proposed rateless scheme generates incremental redundancy until the receiver achieves the successful decoding. The design incorporates algebraic properties of the SDBCs to maintain the diversity, again while allowing the coding rate to adjust without explicit channel state information. The rateless SDBC framework uses the implicit channel adaptation, relying on receiver side feedback to indicate the decoding process. This approach minimizes the need for continuous CSI feedback, reducing the overhead and latency. The adaptive mechanism ensures the efficient resource utilization by transmitting only as much as redundancy as necessary for successful decoding. The proposed methodology is evaluated through extensive simulations. Performance metrics include bitrate error, spectral efficiency, and throughput under various channel conditions such as different levels of path loss, blockage, and user mobility. So the simulations compare the proposed rateless SDBC scheme against the traditional fixed rate SDBC and other existing rateless coding techniques. So what are the outcomes of this research paper on computer networking? So the proposed rateless SDBC scheme significantly improves system performance compared to traditional fixed rate SDBC methods. Secondly, by dynamically adapting to the coding rate based on the real-time channel conditions, the system achieves a substantial reduction in a bit rate and across the various MM wave channel scenarios. The rateless nature of the coding scheme ensures that the system can handle high levels of interference, path loss, and blockage, which are typical in MM wave environments without sacrificing the reliability. So one of the outcomes is the enhanced spectral efficiency and throughput in dynamic MM wave environments. So by eliminating the need for continuous channel state information, feedback, and adjusting the transmission rate as needed, the proposed system achieves an optimal use of available bandwidth. The results in the higher throughput, even in environment with significant channel variation, compromising on the system robustness or latency. So coming to the conclusion of this paper, the robust rateless space-time of coding for MM wave massive MIMO systems presents a novel approach that effectively integrates the rateless coding with space-time block coding, that is SDBC, to address the key challenges in the next generation and to improve the system performance, offering a dynamic and adaptive solution that can handle the unpredictable nature of the MM wave channels, such as path loss, block, and mobility. One of the main conclusions drawn from the research is that the rateless SDBC framework not only enhances the reliability of the communication by reducing the bit error rate, but also optimizes the spectral efficiency and throughput without requiring continuous feedback or channel state information. By adapting the coding rate based on real-time channel conditions, the system ensures that the resources are efficiently utilized, leading to higher rates and a better overall performance in both the line of sight and the non-line of sight scenarios. So thank you for watching my video. Please do like, share, and subscribe this video, and stay tuned for more informative videos as such. Thank you all.